Welcome back to Stationeers, and we had a couple of really eagle-eyed commenters last episode who noticed that I connected this output of the O2 filtration unit directly up to, well, what was going to be going to this with the pressure regulator here pushing stuff this way. So if I put too much O2 into it, it would have exploded this canister. But as it happened, this canister reduced in pressure, so I was just lucky. So I did move that. I did get those two good commenters saying, hey, check that. And this is now working as before. It's set to 8,000 kPa. And that will produce me a nice canister of oxygen. In the meantime, of course, that does mean that this tank is slowly reducing in pressure and volume of gas, but that's fine. It's quite a cool tank. It's freezing essentially of water in Celsius. This one is -40. These, on the other hand, they came straight out of our filtration system, so they're actually quite warm by comparison. 52 degrees, 62 degrees, and 114 degrees for the hydrogen, which will be wonderful. I did get someone saying, hey, watch out that you don't use too hot gases, because you can have things ignite in pipes, and you don't want that, otherwise known as auto ignition. We definitely don't want auto ignition. Now, apparently, according to the spreadsheets that I find online, auto ignition happens at around 570 degrees C at normal atmospheric pressure. But we're quite low in pressure, so I'm not sure if that is going to be needs a much higher temperature. I would assume it does need a much higher temperature, but this is a lower pressure than atmospheric. However, our oxygen is quite high pressure by comparison. Yeah, in fact, no, hang on. Atmospheric pressure is 100 kPa. What's this one? 20. Ah, so it's a fifth of atmospheric pressure. Fine. And you are 3 times atmospheric pressure. Okay, so what we're going to be doing is taking our hydrogen and taking some of our oxygen, and we're going to combine the two. So we're going to need a mixer. Now, I was going to put a building down, but I do need to do a lot more digging to get enough steel for that. So please forgive me if I just put something down temporarily. We're just going to rob this again, and just to demonstrate the concept in this episode, and then I'll show you the building next episode. I did actually want to ask, by the way, do you really want to see the construction of buildings? I'm not sure if you do, or if you just want to see, you know, look at the circuitry and everything else, and well, maybe not too much circuitry, but the pipework, the circuitry, the actual solutions to problems, as opposed to the buildings. Never quite sure about what people prefer there, so do let me know if you've got a particular preference. Where are you? And it's hard to see. Let's see, that's the correct way around. There we go. So if I put it here, you'll get an idea. There we go. So we've got our input and our output as normal at the back. So output at the top, input at the bottom. And we've got to feed, so essentially, stuff into this. And there's a couple of things we can do here. We're going to want to prime this to a certain pressure. And just going off a spreadsheet, I guess the sort of pressure looks reasonable. Is about atmospheric pressure, that is. So around 100 kPa. Our suit is, by the way, our suit is 49 kPa or 50 kPa. We're at half atmospheric pressure. You'd think that'd be a problem, like if you were climbing Everest, it's too low pressure for our lungs. But we make up for it by the fact we're breathing pure oxygen, so that is going to work fine. However, that doesn't affect our furnace. So let's get on with that. So what are we going to put in here? We're going to put in a mixture of gases. Just like before with the volatiles and the oxygen, we're going to want to insert a certain amount of gas, or a certain pressure of gas if you want, because it's going to be a set volume. A particular furnace, we'll have to see. I'm not sure, will the volume pumps let me insert a certain amount of moles, or are they going to be litres or something like that? I never actually checked them. Let's just go and quickly have a look over here. I have a volume pump. If I put you down, what will you let me set to? Litres. Okay, so I'd have to do some calculations for that. Not exactly what I want, so I'm just going to start off with a pressure regulator. Pressure regulator is slow, that's the downside to it, but it just means we can sort a few things out. So I'm just going to get some valves, a pipe mixer, and a pressure regulator. I don't think I've got one hanging around. Let me just make one if we can afford it. Pressure regulator. Are you in here? I always miss the regulators. And again, I'm blind, clearly. There we go, construction kit, because it's got 2. Let's just make one of you and cycle the recipe. I did get a comment as well saying back pressure regulators are not going to be any good for a safety escape system for these. Let me just test that as well. If we put this down and then say we want a back pressure regulator, what can we set this to? Now, the commenter said we can only set it up to about a 1 MPa, I think, but we seem to be able to select it much higher than that. Will this go above 10k and keep going? It's a bit laborious for me to keep clicking this, but no, there we are. So it will only go up to 10 MPa, not 1. That's still too low, however. What we actually want for a pipe is something like 50. So that's 5 times this. So that's not great as an escape system, unless we want to actually escape at 10, which is its maximum. It's not quite exactly what we want. So we may well have to just forget about the idea of a back pressure regulator and just go with a regular pump that's triggered by electronics. Now, we shouldn't get anywhere near that pressure soon. You know, if we just have a look, and obviously these have got quite a high volume, not a high volume as the large tanks, but pretty good. 2, nothing like 1, nothing like 1, nothing like 1, nothing like it. And this is only 2 because we had a filtration system pumping atmosphere into it for quite a while. So yeah, there's nearly 9,000 moles in there. So yeah, we've got plenty of time to consider a solution for that. Obviously, if you want to suggest one, feel free to put it in the comments. But I think what we'll have to do is build a circuitry system for that. Slightly annoying in that I'll either have to build it, I think, without building something immensely complicated, that is. Keeping it simple, I'll probably have to build one for each tank. We could make it so that it would read any of the inputs for any of the tanks and then escape all of them, i.e. just dump some of the tanks until the maximum one fell below our escape value. For example, if this one was highest, it would open this one and that one and that one and that one and that one into our overflow tank until this got to safe levels. But that's not quite as useful. It's almost like you want to build one per tank that just says, hey, if this gets too high, escape this into our overflow system, and we won't put the overflow system back into the inputs until, you know, we figure out what we want to do with the CO2. We could just sort of equalize this with a portable tank like that, put it into a port next to it, and then the two should even out depending on what the volume of this is a little bit. Not quite sure yet. Obviously, more than happy to hear comments. However, let's get going with this. So pressure regulator, can we now put these right next to the furnace? We can't. That's a shame. Shouldn't matter that much, but it would have been nice. Just saying. Nice not to have to connect pipes to these all the time. There we go. So pressure regulator, and of course the power is on the wrong side. Just so happens. And we want this to only up to 100. Oops. That's annoying. Is there any... there's just one, or there's 50. Right. So, while I click 50 times and wear at my index finger, this is going to ensure that whatever's after it is going to be 100 kPa. In here and the furnace. Both of those blocks together. We might have to insert it a bit more because this is going to be an extra volume compared to the furnace, but 100 kPa. Behind that, we're going to put a gas mixer, and that's going to need a pipe as well. Oh, that's so annoying. Right, another pipe. And a gas mixer. Alright, so the gas mixer has a couple of inputs. We have... I think it's labelled actually if you get close enough. Gas input 2 and gas input 1. Well, input. And then you have a dial on top here, which if I get close enough to it, dial on top, which lets me set the ratio of 1 to 2. So at the moment it's 50% from 1, and let's assume that 1 is going to be hydrogen. It's close enough. So 1, we actually want this to be something like 2 to 1, so that's going to be 66 for number 1. So let's just bring that back to 670, 66 and 34. don't think we can get any more exact than that, but that should be close enough. And then gas 2, we're going to be bringing in this side from our O2 system. Reasonable, hopefully. And then, of course, we're going to have to connect that up. And that won't be terribly hard here, at least in the demonstration system. So let's just bring that over with a corner. We can connect it up to here. Do I want to connect it over here? That's it. Let's just put a corner in and another corner. There we go. And we'll connect that in a second. In fact, let's just do it now. Where's my wrench? And a T-junction. There we go. So that's being fed from the H2 system. And if we just drop that for a second, we can just check. Yep, that's below 100 degrees C now. And then we have the oxygen side, and I should probably call this white. In fact, yeah, you can do a whole stack of this at once, I think, if I remember rightly. So let's just get this set back to kit pipe. There we go. And build. We've got enough for 80 of those. So let me just do a full stack in white. Let's just put the tool away. Do I have white around anywhere? I thought I did. That's annoying. Where's my white paint gone? Is it my backpack? It is in the backpack. Okay, so let's just grab a stack, drop it on the floor, and then we can spray the whole thing once it stops rolling. There we go. So we've essentially got oxygen pipe. It only uses one, I think, one sort of ration, one dose of paint. There we go, and I'll put that in my backpack. Alright, so this side is going to be reasonable to get connected. Remember, it doesn't much matter where it is, as long as we don't put it here. It can go here just fine. So we're going to want to go up, I think, to do that. So corner up. And then the same thing here. Like this. Obviously, I'll rework these in between the episodes, but that is fine for now. And coming this way. And what we should end up with is a complete mix of gases in exactly the right ratio. So let's just drop that for a second, and I'll put that back in my backpack, grab my tablet. So we've got, oh, that needs to be connected. I need one more piece. Just let's connect that. Grab you. There we go. Now we should be connected. Yeah, O2, H2, and now I just need to put some cable coil in place to enable this to be turned on. That'll then have a mix of gases in this. It will be unregulated, so that's something we have to consider, I guess. Although it should just fill up to, well, kind of, I wonder if the gas mix, what the pressure does. That's an interesting one. Is it just the combination of both of these and average them or something? Or is it just, well, it should just be dominated by the pressure of this. However, because this is mixing the two, it shouldn't let, yeah, if this is going to go empty first, it shouldn't let it be dominated by O2 because it maintains the ratio. So that'll be an interesting one to see what happens. Let me get some cable coil and let me just wire that up, and let's take a look. Okay, so I've now hooked the system up and I've turned both of these on. There is a bit of an issue. And just as the commenter said, I forgot your name, but you did mention that about the auto ignition in the pipes. Well, yes, this is what happens if you have auto ignition in the pipes. See how the pressure is 33 MPa? That's halfway to bursting on that pipe. And all of this pipe has O2 only, and this pipe has H2 only. As soon as they mix, and in this case, they only mixed, this H2 tank is at 71 degrees. The O2 tank is at -3 or something like that. Yeah, -4. As soon as they mixed here, we got 1900 degrees. Now we have CO2 and we have pollutant in here. And unfortunately, that now means that this is pretty redundant, this pressure regulator, because it is actually regulating. If I just show you here, oh, I'm out of batteries. That's annoying. Let's just go and grab another battery. Yeah, there we go. It is regulating to 100 kPa, but that's nowhere near enough for the furnace. You'll see there's a very faint glow if I just cover it with my shadow. Yeah, so if we want to actually just clean the system out, we can just, I think, just disassemble this. Hopefully none of this will kill me. Let's just get rid of you and replace you with a bit of pipe and rotate. And now our furnace has come online without even the regulator. Not exactly what we want. What I think we want is to keep all of our gases chilled and have it only mix a certain amount in the final stages and then prime it up to a certain temperature, pressure even, then ignite it. However, you know, this will probably do for our immediate needs. Let me just take a quick look at what we need. So for our metals, the only one that seems weird and hard to actually get to happen is Constantan, and that's copper and nickel. And that has a maximum pressure of, maximum temperature of 1500. So we're way above the temperature it needs. When we actually prime this properly, what we should end up with is a temperature of just below 2000. And that's enough to, I think, do all of the other stuff. So steel, electrum, I want to say Invar as well, but Invar's got another weirdness in it needs to have a high pressure. So Invar and Constantan are the two special cases. For the pressure, we need at least 6000, and this is only a quarter of that. So we're going to have to prime it a lot more. Probably going to be something like 300 kPa instead of 100 kPa, something along those lines. And then we should get enough for Invar. So I think what we may do is have 3 parallel setups for this. Once I attach radiators, of course. I'm not going to try auto-igniting in pipes. It does work, and it does start the furnace going, but without even pressing that button, but it's not really something we actually want. So if we have a look here, this is it down at 1.55 MPa now. Okay, and what's this pipe at? Yeah, that's used up pretty much all of our H2, just doing that. So, I didn't put a valve in here. I should have put a valve. Where's my valves? Valves in my backpack? Valves are in my backpack. I should put a valve in there just while I'm experimenting. Just so everything doesn't immediately go back out to this tank connector. And in our case, we'll get rid of it to this tank. That is, of course, at 2000 degrees. So we need some kind of chilling system to build this into, and I think what I'm going to do is have a separate tank with a valve, and it probably will be a digital valve eventually, but we're going to put it out here in our furnace room. It can be one of these, doesn't have to be anything specific. And then we're going to attach lots of radiators to it, just like that system up there. The only difference is that is coming from a wall cooler, and we're not going to need a wall cooler. All we're really going to need is just a pipe connected to our tank with lots of radiators on it, and that should chill our tank back down to ambient temperatures, so, you know, minus 60. And then when it comes out of that tank, hopefully it'll be low enough temperature not to cause auto-ignition. So that's what I want to do between the episodes and build up a building. We'll see next episode. This is going to be a bit of a short one, just demonstrating what we're going to be doing and what not to do in my case. Yeah, so this works perfectly well. It's only what input you put into it is going to be a problem. And I guess you could also have these pipes wherever they go over the top into a new building, have radiators on them there, but we may be pressurizing this whole area later, so we're probably going to want something out into the open that has those radiators. However, radiators do actually consume a fair amount of steel. So I'm going to need to go and get yet more iron. Again, that ground penetrating radar is going to come in very, very handy between the episodes. So I hope you've enjoyed this one. It's going to be just a bit of a short one, just a bit of a tutorial one of getting this set up. We could even add a digital valve in here as well and have that triggered remotely so that you just press a button here, it primes it, closes off, Once we get to use a pipe analyzer, we can put that on there, read the value of the pipe analyzer for the pressure, and as soon as it hits 100, we can turn off the regulator that will be here, and we can even turn off the gas mixer, to be honest, and then push the activate button, and then that will start it up. And at that point, all you have to do is drop your materials in, and we can actually just put ductwork up here as well if we wanted to. I've not shown that in this season, but I did it in last season as well. You have ductwork going in, and you can have ductwork, maybe not ductwork coming out, but certainly ductwork going in, and you just got to avoid jams there. But we'll figure that out between the episode, well, next episode, or maybe the one after for ductwork. Not quite so sure. The idea eventually is that we can just have a series of inputs where we can say, let's say this furnace is for Invar, we've got one for Constantin and one for everything else. And maybe the one from everything else has the ductwork in it, and you can just basically load up with a stack of one thing, a stack of another thing, press go, and away it goes, and just gives you what you want back out. And we can think about more expansive systems later. But for the meantime, yeah, I'm going to get on with building a building, and we'll see you next episode. Thanks a lot for watching, guys, and I'll see you next time.